Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. My name is Ravinder. I am assistant professor with the ETC department, and today we are going to discuss the topic of polymorphism. We are discussing this topic of polymorphism for the subject called Object Technologies and Programming, and we are discussing for the last few lectures the basic building blocks of OOPS. Okay, so today we are going to discuss. Yesterday we have discussed about the inheritance. What is the basic we have got the basic understanding that what is inheritance, and today we are going to discuss what is polymorphism and how it is essential and how it makes the OOPS paradigm so strong. Okay, you have to wait just 1 minute. Just hold on. Yeah. Okay. So let's head back to the notes. I'm not going to make this lecture long because the few of the things that I am going to say here is not going to make much of a sense at this point, but after a few lectures or after second unit, all these things will make sense. So you are advised to go through these lectures again after second unit. Okay. So what is polymorphism? Now, polymorphism in Java is a concept, or in OOPS is basically a concept by which we can perform a single action in different ways. So polymorphism is derived from two Greek words called poly and morph. The word poly means many and morph means form, so many forms. So polymorphism means many forms. Now there are two types of polymorphism in Java. First is compile type polymorphism and second is runtime polymorphism. Now we can perform polymorphism in Java. I'm using Java instead of OOPS because that is the language, that is the preferred language that we have chosen to study this particular subject called Object Technologies and Programming, that is OTMP. So it is in your syllabus, so don't get confused that why we are switching from OOPS to Java. When I'm talking for Java, then you must understand that Java is just a platform through which we are going to understand the concepts, or through which we are going to implement the concept of OOPS and nothing else. Okay. Okay. Now we can perform polymorphism in Java by method overloading and method overriding. Now what is method overloading? What is method overriding? I'm going to tell you in a short while. Now if we are overload a static method in Java, it is the example of compile type polymorphism, and we'll focus on the runtime polymorphism in Java. Okay, all these lines will make sense in a while. Now first, let's understand what is runtime polymorphism. Now, if someone asks how many types of polymorphism we have, then you must answer as runtime and compile time. So runtime polymorphism, or it has one another fancy name called dynamic method dispatch, is a process in which a call to an overridden method is resolved at runtime rather than in compile time. Let's focus first on the word called overridden method. Now, the meaning of polymorphism is to perform a particular task using many forms. Now, suppose you want to calculate, say, the interest from for a particular amount. Okay, so you have created a method in which you have asked for what is the interest that has been told to you, that has been conveyed to you at the time of the contract. Okay, if the user is able to convey to you that what is the interest rate that has been applied to the amount which he has borrowed from the bank at the time of the contract, then that particular method will calculate the total interest amount. But if in some case it doesn't specify, the user fails to specify what is the interest rate at the time of the contract, or it was by default, then in that case your method will not be able to have the argument called interest rate, and if it doesn't have the argument interest rate, it will not be able to perform the task, that is to calculate the total interest amount. So in that case, we will actually build two methods of same name. Okay, we'll build two methods of same name, but of a different type. It will have a different body in it. So the signature of method will be same. By signature, I mean name of the method. Okay, how many arguments will it take? And secondly, what is the type of data it is going to return? So that is called the signature of a method. I think you must be familiar with signatures already because you have already gone through your C++. So signature of the method will remain same, but the body of your method will be different. If the argument comes out to be default, that is the user doesn't know, or the user says that it was default at that time, in that case the calculation of the interest will be different for that particular user. Okay, so this is called method overriding. Usually the method overriding works as, we will describe a method, or will provide the body and signature of a method in a super class, that is the parent class, and in the child class we'll again try to build that method, but we'll provide with the method with same signature but with a different body. By different body, I doesn't mean that it is going to do something different, but it is actually going to do same work but little bit differently. Okay, little bit differently this time. So this is what is called method overriding. Okay, so in this process, an overridden method is called through the reference variable of a superclass, and the determination of the method to be called is based on the object being referred to by the reference variable. So let me tell you what we are trying to achieve. Now, as you know, we have already seen that. Let me go to the example first. That to create an object of a particular class, this would be the line. Okay, this would be the line by using the keyword new. Okay, so what we have done here, this is actually your runtime polymorphism in action. As you can see, by new Splendor, I mean that I am going to create an object of class Splendor, but it is actually of type bike. It is actually of type bike. If you return to your last lecture in which we have used inheritance, I have created a new object, but in that particular object, the type of the object, okay, the declaration of the object and instantiation of the object are same. It means Splendor B is equal to new Splendor. That means type of the object is Splendor, and actually the object which is associated with B is also of Splendor. Instantiation is also of Splendor, but this time the object that is instantiated is of type Splendor, but actually the type of object is bike. Now bike is parent class and Splendor is your child class. Okay, now at when you write this kind of statement, your compiler will not know, because according to the compiler, Splendor is also a bike, so he is okay with it. According to it, he doesn't know what kind of let's say what kind of object is created here. But at the runtime, your run Java virtual machine, that is the machine which is actually responsible for running Java files, okay, your Java class files onto your machine. Okay, Java runtime is actually the software that is responsible for running your Java files into your machine. Your machine means your system. So your Java runtime will actually decide what kind of object it is going to be. As we have discussed yesterday, a particular superclass can be extended by many of its child classes. So there could be Splendor, there could be Charisma, there could be let's say Enfield Bullet, there could be many bikes. So many classes are there which are all extending the one parent class called bike. Okay, so which, and we have, as you can see, by referring to the object B, I have also called a method called run. Now this method run, which method this method run is actually defined inside the bike as well as defined inside the Splendor. As you can see above, this method run is actually defined in the bike and then again defined in the Splendor class. So which run method will be there depends on the type of object that is instantiated. Now object is of type B, but with or the variable is of type bike. I would say the correct terminology will be the variable B is of type bike, but the object with which it is associated is of type Splendor. So when this kind of statement when you will write this kind of statement, this is actually your runtime polymorphism in action. Okay, so run method has a different forms. It has one form in bike class, it has other form in your Splendor class. So which method will be used to run, or which method is being called here, depends on the type of object that is been associated with the variable B. The variable B is actually of class bike, and this cannot be done at the time of compilation. This will be done at the time of runtime. So that is why this kind of polymorphism is actually called runtime polymorphism, because it is decided at the runtime. This okay, this variable B is of type bike. It means the object could be of type bike or any of the classes, subclasses which are extending the bike class, but the actual object to which this variable B is referring to is decided by the name after this keyword new. So Splendor is the name of the object which is being associated with the variable B, which is of type bike. So method run, which has been called here, is not inside the bike but inside the Splendor. So what will be your output? The output will be running safely with 60 kilometers instead of running. So this is your method overriding in action. This method run is already been defined in the bike class. The Splendor class actually extends the bike class, that is your inheritance in action. And inside this class we have the same method called run with same signature. As you can see, no arguments, and return type of both of them is void, but the body is different. Okay, so this is your method overriding in action. And when you will call this method by using this kind of statement, that is you will declare a variable B of a superclass and then calls the or associate this variable with a object of one of the child classes. This is your polymorphism, runtime polymorphism in action. Okay, so I think I have made myself pretty clear what is your runtime polymorphism in action. So let me read that again. In this example, we're creating two classes, that is bike and Splendor. Splendor class extends bike class and overrides its run method, and there it is. Bike class also has a run method and Splendor class also has a run method. Okay, we are calling the run method by reference variable of a parent class. How do we know that? Because B is a variable of type bike, which is actually a parent class of Splendor class. Okay, and since it refers to subclass object, how do we know that? Because the object is created by the keyword new and it is of type Splendor, which is actually subclass of bike class. Okay, it refers to subclass object and subclass method overrides the parent class method. So when this variable B actually refers to the object of a subclass, the method of the same name, which is actually the method which has been overridden, will be called, and not the method which is actually inside the bike class. So the run method inside the Splendor class will be called instead of the run method inside the bike class. Okay, the subclass method is invoked at the runtime, and this is what we are saying for the last few minutes. Now, since method invocation is determined by the JVM and not the compiler, as I've told you already, so it is known as runtime polymorphism. So this is your runtime polymorphism in action. This will may not make sense to you right now because it's a pretty advanced topic, but I have given you a very brief idea what is polymorphism in action. Okay, so your bike can run with a method which has been defined inside the bike class. Your bike can also run with a method which has been defined inside the Splendor class. Okay, which type of running will be there and which, or you can say which type of method will be called, depends upon what would be the type of the object which has been instantiated or which is associated with a variable called b. Okay, I think it I have made myself pretty clear now. So next type of polymorphism will be, there's one more method here, is your compile time polymorphism. Okay, it's getting too long. Now in Java, many other object-oriented, like Java and many other OOPS languages, allows you to implement multiple methods with same class in the same class that use same name but different set of parameters. In the previous type of polymorphism, the method's name are same, the method's signature is same, but the body of the method is different and they are in other different classes. In this type of polymorphism, methods name are same, methods body may be different or may not be different, but the signature of method is quite different to each other. That is, it may be the return type or it may be the number of arguments. Okay, so how can we do that? uh, okay, that use same name but different set of parameters. Now this is called, actually called, method overloading. The previous one is method overriding. This is actually your method overloading and represent a static form of polymorphism. Okay, now why static? Because it will be caught by the compiler, it will be performed by the compiler, not at the runtime. Now the parameters said to have differ in at least one of the following three criteria to fit in the method overloading parameter. First is they need to have different number of parameters. That is, one method accept two and other method accept three parameters. That is the argument. I think you people are familiar with the argument right now. Okay, so let's say if we have instantiated inside the Splendor two types of run method. In one method it will accept one argument, and second run type of method it will accept two arguments. So in that case you can say that the run method has been overloaded. We have two forms of that, one accept one argument and other one accept two arguments. So the name is same but signature is different. Now the next type could be the type of parameter need to be different. That is, one method accept a string and other accept a long or an int or a double. Okay, so the number of argument could be same, but what is the kind of data, what is the kind of argument it is actually accepting may be different. Okay, and the last one is they need to expect the parameters in different order. That is, one method accepts a string and a long, and other one accepts a long and a string. So ordering could be different. Now this kind of overload is not recommended because it makes the API difficult to understand. So don't go into that. So these are the three kinds by which you can perform the method overloading. Now in most cases, each of these overloaded methods provided different but very similar functionality. Again, run, the ultimate function of run is to say to us or to inform the user that your bike is running. But how it is going to perform, on what kind of arguments it is going to perform, or how many number of arguments it is going to decide whether the bike is running or not, depends upon the method, body and signature. So these are your method overloading and your static form of polymorphism or your compile time polymorphism. Okay, so I'll end this lecture now. I think notes are with you, and tomorrow we are going to start a different topic called abstraction, the third pillar of OOPS. Thank you.